All right, so chapter 9, multivariate correlational research. So in this chapter, little chapter overview, I'm going to review the 3 causal criteria, which we've done multiple times already, but going over that one more time. Establishing temporal precedence with a longitudinal design, ruling out third variables with multiple regression analyses, getting at causality with pattern and parsimony, mediation, and then multivariate designs and the 4 validities. So I already posted the activity for chapter 9, which basically is just kind of the check your understanding questions that are throughout the text. So if you do that activity, I would recommend doing it as you're reading the textbook, and just kind of as you go, make sure that you're understanding what you're reading. Yeah, so let's get started. So the first thing is a review of the 3 causal criteria. So in the previous chapter, we talked about bivariate designs, bivariate relationships, which is a relationship, a correlation that has 2 variables. This chapter, we're looking at multivariate designs, which is just a correlation or study or something that's looking at more than 2 variables. So from 3 variables all the way up to 1,000,000 variables or whatever, right? Just something more than 2 measured variables. And it's going to be correlational still. So you're measuring all the variables, right? 2 measured variables. You're not manipulating anything. In the correlational study, you're not actually doing an experimental design. You're just, recording information and looking at any patterns between your variables. And this can be done a number of ways. The main way we're going to be talking about is a longitudinal design. And this is important. This is a good way to do a multivariate study because it's allowing you to gather information about temporal precedence because you're measuring the same variables from the same people at several different points in time. So it allows you to go back and look at the history, the progression of these different variables, and see how they may be related to one another. But again, for establishing causation, we have covariance, which just means the 2 variables are related in some way. So association claims have that as well. But again, for a causal claim, we also need covariance to be seen. Temporal precedence, which is just showing that one variable causes the other variable to change. In a bivariate correlational study, that's kind of difficult to do, right? Because you only have 2 variables, you're measuring at one point in time, so it's kind of impossible to figure out, which one came first, unless we're doing an experimental study. But in this case, if we're doing a longitudinal design, measuring the variables multiple times over the length of some sort of time period, that'll allow us to look at temporal precedence, which is why a multivariate design in some cases is better than just a bivariate. And then the last bit is internal validity. So again, that third variable problem, is there something else going on that might be explaining the relationship of the first 2 variables? And multivariate designs kind of help to get rid of any internal validity problems, but it's not going to be foolproof because, again, it's just a correlational study and you're not looking, not doing an actual experimental design. But again, we've talked about these 3 criteria. This is on your first exam, definitely going to be on your second exam as well. So if you don't know these by now, make sure you are looking into those. Okay. So that's just kind of an introduction to the chapter. The next little section, establishing temporal precedence with a longitudinal design. So looking at what a longitudinal design actually is, looking at the results of it, using the 3 criteria for causation, and then talking about why we don't just use experiments, which is pretty self-explanatory. Oh my gosh, Stella is so loud. The results that we get from a longitudinal design, we can interpret 3 different ways. So there's going to be slides on all of these in a second, but the first, cross-sectional correlation, autocorrelations, and then Crosslag correlations. So these kind of look similar, but it's really important. They're very different, so it's important that you can distinguish between these different types of correlations. But again, all of these are coming from a longitudinal design, so measuring variables from the same population, same sample of the population over an extended period of time, multiple recordings. So the first Cross-sectional correlation is looking at whether two variables measured at the same point in time are correlated with each other. So this is pretty similar to just like a bivariate design, right? Looking at two variables and then looking at the relationship at a single point in time, which is what you would do with any bivariate study, right? So the example that your book's going with is looking at narcissism, so narcissistic traits in children, and then how their parents praise them. So your book gave the example of just like the parents telling their kid that they're great and wonderful and praising the kids a lot. They think that might lead to narcissism. So they want to do a study to test that. So they would measure the parents' praise to the children over valuation at 4 different times, right? Longitudinal study. Measure that 4 different times, and then at the same time you're measuring that in the parents, also measuring the narcissistic traits in the children, right? So a cross-sectional correlation is just at each point in time when we're measuring, looking at the relationship. We have R here, the correlation coefficient between the overvaluation from the parent and narcissism, at each point in time. Which is important because it tells us if there's any sort of correlation between the two variables. But again, the point of a longitudinal study is having some sort of interaction across this time. So cross-sectional correlation isn't really going to tell the researcher very much, especially as far as trying to establish some sort of temporal precedence, right? This will show covariance, showing that these two things are actually related in some way, but not doing anything for temporal precedence. Okay, so cross-sectional correlation. Autocorrelations, the next type, again, longitudinal study looking at the same thing. Autocorrelations is looking at the correlation of each variable with itself across the length of the study. So here you're looking at the narcissism at time 1 compared to at time 2 compared to time 3, and so on. So just looking at a single variable across time, is it changing dramatically? Is it kind of consistent? Is it increasing then decreasing? And again, this one doesn't really show too much as far as establishing causality, but it's kind of interesting to see across time for each variable what exactly is happening. So that's an autocorrelation, looking at each variable, how it changes over time. And then the last type of correlation in a longitudinal study, which is the most important, is a Crosslag correlation. So this, instead of looking at, at time 1, the relationship, at time 2, the relationship, or at a single variable across time, you're starting to cross over. So looking at the effect of this overvaluation from the parent at time 1, what effect that has or correlation that has on narcissism at time 2, and vice versa. So narcissism time 1, what effect that has, correlation that has on the parental praise at time 2. So this is important because it's giving us an idea of what's actually causing the other one to change, right? It's establishing some sort of temporal precedence. You can see here there R values are noted for how the correlation between parental praise at time 1 and narcissism at time 2, so on and so forth. Right, so we can see that there is a correlation from the overvaluation to narcissism in all cases, right? But the other way, narcissism isn't leading to any sort of change at time 2 of the parental praise. So this gives researchers a better idea and more ability to say that this parental praise, overvaluation from the parents is leading to the change in narcissism and not vice versa, right? Since we only have, any sort of effect size going this way, and we have no significant effect size this way. So that's very important for establishing temporal precedence. Like it says right here, establishing temporal precedence. All right, so there's 3 potential things you could have, this show. So what it's showing right now is showing that this overpraise or the parental praise is significantly correlated with narcissism at a later time and all situations. So overpraise correlated with narcissism, overpraise correlated with narcissism later on, right? So that's showing that there's a temporal precedence with this praise leading to narcissism. So this is what we have here. It could also show something the opposite. So if we saw these two arrows kind of flipped, we could see narcissism leading to parental praise, which potentially could happen if you have a narcissistic child. Maybe they're just so overbearing or whatever on their parents that their parents just give in and tell them they're doing great just to avoid whatever the narcissistic traits of the child, right? So maybe the narcissism actually was leading to the overvaluation, but this shows it's not. You could also have a situation where both correlations are significant, right? So this overpraise at time 1 leads to narcissism, and also vice versa. You could have narcissism leading to this overpraise. So if you had that result, it would not establish any sort of temporal precedence. Basically, that would just say that these excessive praise from the parents and narcissistic tendencies are just, mutually reinforcing. So they help each other out in both cases. But 3 different correlations you can look at with longitudinal studies. Okay. Which again, really important for establishing causation is being able to look at all those different types of correlations within a longitudinal study. So if we're trying to establish covariance of a longitudinal study, you're going to want to look at that cross-sectional correlation, right? So at time 1, how did that overpraise and narcissism, was there any sort of effect size there? So cross-sectional study, remember, it was at each point in time, you're looking at how the 2 variables are correlated. And that would give you if any sort of covariance for the study. Whereas temporal precedence, you'd want to look at that cross-lag, looking at, overpraise at time 1, narcissism at time 2, and trying to determine if there's some sort of temporal precedence there. And internal validity, again, we're doing a multivariate study here, so we're going to be looking at more than 2 variables. We haven't talked about it yet, but we can try to control for some sort of internal validity, try to rule out third variables in a multivariate design, but it's never really going to be perfect because we're not doing an experiment. And we'll talk about this a lot more in the later slides for this chapter. But why not just do an experiment? This should be pretty self-explanatory, but in many cases, participants can't be randomly assigned to a variable. So if there's like preferences that you're trying to look at, you can't necessarily tell people what they need to be interested in or what they want to, do, whatever. And also in some situations, it's going to be unethical to assign participants to different groups. So if you're giving participants, some participants a lot of praise from their parents, the other group, maybe you want to see how, negative talk affects narcissism, and having parents like talk down to their children. It's kind of unethical to create an experimental setup where, you're having kids be potentially verbally abused. So obviously we can't do an experiment and assign people to groups like that. So again, just blew some examples. Researchers cannot manipulate personality traits such as narcissism in children. We're not going to tell children to be narcissistic, right? Parents can't be assigned to daily parenting styles. Again, parents have their own ideas of how they want to raise their children. It would be unethical to make parents treat their children in certain ways that especially could have negative implications on the children later on. And yeah, it'd be unethical to assign children to conditions where they receive a certain type of praise, especially if it's for an extended period of time. And especially if we suspect that one of the types of praise might make children narcissistic, right? So if we know there might be a negative outcome for one of the types of praise, whatever it may be, obviously it's not very ethical to assign children because it could potentially, again, hurt them later on. So we can't always just do an experiment. So sometimes we just have to look at some correlational research. And again, this chapter you're looking at multivariate gives us ways to kind of increase internal validity a little bit, and we're going to talk about that next. Okay, so next little section, rolling out third variables. So measuring more than two variables, regression results indicating how a third variable affects the relationship, adding more predictors, regression in popular press articles, how journalism talks about it, and then talking about regression and causation. So again, just section headings there. But typically in the last few chapters, again, we've been talking about just bivariate two variable associations, which would look something like this. This is what kind of we've been talking about. So this example, the next few slides are going to go over as well. Researchers wanted to see if there was a relationship between exposure to sexual TV content, so lots of kissing, intimate scenes, that type of thing. If the more exposed individuals were to sexy TV, as your book called it, what effect that had on their risk of getting pregnant. So you could just measure those two variables, measure how often someone watches sexual TV, and measure, the risk, how often they get pregnant, I suppose. But obviously there's a lot of other things that could be going on that wouldn't be accounted for in just a bivariate design like this. So multivariate design, on top of measuring just these two variables that we're actually interested in, we'll measure multiple other variables, things such as like age, gender, socioeconomic status, how much money people make, I suppose, measuring different things that could have an effect on this relationship, to try to rule out potential third variables. If we have people responding to a questionnaire or survey about this information already, it makes sense just to add in, additional questions so we can rule out different things. Okay, so an example of that, say we want to look at age, see if age as a potential third variable that's affecting pregnancy risk and exposure to sexual TV content. So the idea, well, maybe older individuals watch sexual TV more because they have access to it, are older, whatever, more mature, so they watch more sexual TV, and older individuals also are at higher risk for pregnancy because, they're older, have more sexual partners, that type of thing. So we want to measure for that additional variable to see if it's actually affecting our results at all. So if we were to separate these by age, so all the points in the last graph now assign ages to each of these individuals on this study, we can control for age. So controlling means holding something constant. So in this case, all the individuals who are older, there is a general trend that they are higher risk of pregnancy and higher exposure to sexual TV content, but you still have that same, if you look at just the orange numbers, the 20s, you still have a positive association, right? If you were to draw a line that's fitting this data of just the 20s even, you would see a positive correlation, right? Just the 18s as well. Again, generally, they're less likely to watch sexual TV and less likely to get pregnant in general than 20-year-olds, but you still have a positive correlation even within that group. And then again, for 16-year-olds as well, you would still have a positive correlation, even though in general, the frequency of sexual TV content and pregnancy would be lower in general than 20-year-olds. So even if we look at that third variable, it may have some effect, some correlation with how much sexual TV they watch and the pregnancy risk, but still within each of the group, if we're controlling for that third variable of age, we still see a positive association between the two variables in question. Right, so that might be a way we look at and add another additional variable into the study. Your book gives an example if we did the same thing but got different data. So this would be showing an example if if the results looked like this instead of this, you see the difference? This would be a third variable problem, because within each subgroup we don't have that positive correlation with sexual TV content and pregnancy risk. We talked about this in the last chapter as well, but if we look at just 20-year-olds, there would be probably, if we were to actually do the statistics, zero association now in just 20-year-olds between pregnancy risk and exposure to sexual TV content. Same as 18-year-olds, right? A line through that would probably be pretty flat, and 16-year-olds as well. So if we end up with data like this would definitely be a third variable problem. And again, remember, third variable problem is we have a confounding variable, which in this case would be age, which is the only reason we see any relationship between exposure to sexual TV and pregnancy risk, right? Without these differences in age, we wouldn't have this correlation. Whereas in here, again, just trying to reiterate this, individual groups still have that positive correlation. Even though there might be subtle differences between age, in general, we see a positive correlation for all the groups. And here in each group, there's no correlation at all. So this would not be good. This would kind of be definitely a third variable problem, having a confounding variable. But the whole point of multivariate designs is to try to control for these third variables, fourth variables even, right? Just additional variables that might be affecting the research. So typically how this is done, or how this is noted in research articles, is through regression results, right? So there's tables formed. It's going to say multiple regression results from a study predicting pregnancy from sexual content on TV and age, right? So this is what we just looked at. So on this table, you're going to see criterion variables, predictor variables, and then something known as beta, right? So the first criterion variable is what the dependent variable is, which is what the scientist is most interested in understanding and predicting. And it's going to be specified in the title or the very top row of the regression table, right? So criterion variable, pregnancy risk, right? So what scientists for this study wanted to see is how watching TV affected the pregnancy, right? Pregnancy risk. So pregnancy risk would be the dependent or criterion variable. Predictor variables are the independent variables, and they're going to be listed below. And all of these are going to be things that the researcher is asking to see if there's any sort of correlation with the pregnancy risk, right? So criterion, dependent at the top here, all the predictors, so exposure to sex on TV, age, are all going to be listed down here with an associated beta, okay? So what is the beta? So if you look at this table again, you'll see the beta column. Sometimes it's denoted with like a Greek letter beta. I don't know if it's Greek, but like a B with a long bottom sprout, whatever it's called, right? The stem's longer. So beta is used in multivariate correlation studies, and it's very similar to an R value, right? So a positive beta value, like these ones here, 0.25 and 0.33, are indicating a positive relationship. So 0.25 for exposure to sex on TV. So there's a positive relationship between how often someone is exposed to sexual TV and their risk of getting pregnant. So as you increase exposure to sexy TV, you're also going to increase your pregnancy risk, right? A positive association. Again, age has another positive beta. So as you increase age, again, it's going to increase your pregnancy risk as well. Okay, so that's what a positive beta means. If you had a negative beta, it'd be similar to a negative R. So as one variable increases, the other variable will decrease. So age, again, maybe as you get older, the pregnancy risk decreases. If you were to look at maybe women who are older than 50, right? As you continue to get older and older, maybe your pregnancy risk would decrease. In that case, you would see a negative beta. A beta that's 0 or pretty close to 0 suggests that there's no relationship, right? And beta is interesting because it's controlling for the other variables. So it's not just a bivariate relationship where you're looking at exposure to sex on TV and pregnancy risk independently, right? You're looking at how these are related if we're controlling for age, okay? So beta values are taken into account of all of the other variables that you measured, and making sure that they're not actually affecting the other ones, if that makes sense. Okay, so I know this is a lot of text, but interpreting beta. So again, similar to R values, positive means there's a positive correlation, and closer to 1, the higher the number is, the stronger the relationship is. So in this case, age would be a stronger predictor of pregnancy risk than exposure to sexy TV, right? Because this is closer to 1 than that. And again, beta is looking at if you're controlling for the other variables on this regression chart. Okay. And then again, like R, if I go back, sorry, real quick, there's also a column here for sig, showing if the data is statistically significant or not. So in this case, it denotes P is less than 0.001, which is statistically significant. So same as we talked about before, if P is less than 0.05, beta is going to be statistically significant. So the same as we talked for the R values. And if we have significant betas, we can describe it in multiple ways. So these are just some example sentences. So the relationship between exposure to sex on TV and pregnancy is positive, even when age is controlled for. What this says, I skipped that. But yeah. The relationship between exposure to sex on TV and pregnancy is positive and is not attributable to the third variable of age because it holds even when age is held constant. Right, so just different ways to word it, examples, just so you guys get an idea. That's straight from your book. If beta is not significant, right, so in this case, this beta value is not significant. This study is looking at academic success, which is a dependent or criterion variable, and different independent variables, frequency of family meals, and parental involvement. So seeing if, eating more meals together leads to academic success. And if you do a multivariate study with this and control for parental involvement, so just parents being involved, in general, not necessarily meals together, but just being involved in their kids' lives. If we control for parental involvement, then we don't have any significant effect of family meals on academic success, right? A beta negative 0.01, not very strong to begin with, and then also not statistically significant results there. So that's what that would look like in a table. And again, just different sentences to try to explain how to put that into words. Okay. So up to this point, we talked about pregnancy risk, right, and exposure to sexual TV content, and looked at just one other variable, which is age. But if people were to actually be doing the study, they would include as many independent or predictor variables as they could. The reason for this is if you include all of these, you're counting for all of these potentially being third variables, and increasing the internal validity to an extent, right? So it helps to control for several third variables at a time. And then remember, the betas are going to take into all these other variables into account. So for a fact that exposure to sex on TV has a positive correlation with pregnancy risk, even if you're taking total television exposure, age, low grades, parent education, educational aspirations, being Hispanic, being Black, being female. All of these other things are taken into account, and exposure to sex on TV is still correlated with pregnancy. So you can see how this type of study, a multivariate study, would be better than just bivariate, because you're taking control of all these other potential third variables that could harm the internal validity of the study. So you can see this example, a strong predictor is gender. Where is it on here? I don't even see it. Where's gender? 1.2. Being black is 1.2. Being female here. Female. Beta of 1.2, right? So even when all the other variables are controlled, that strong beta value shows that being female is a strong predictor of pregnancy risk. And I think in the study they did ask like males also to participate and asked, how many females have you gotten pregnant? Females, how many times have you been pregnant? And you'd think that, that wouldn't necessarily be a strong predictor of getting pregnant or getting someone pregnant, getting pregnant in general, because you need two to tango. But I think the book said that, perhaps men, when reporting on this questionnaire, they don't know for sure if they got someone pregnant, where females, if you get pregnant, So kind of interesting. All right, in popular press articles, if you see a headline that uses any of these statements, then you can assume that's a multivariate longitudinal type study, because if you're controlling for, taking into account, correcting for, or adjusting for a different third variable, fourth variable, whatever it may be, that's showing that you're looking at a beta multivariate design and not just two variables, right? So there's a bunch of examples in your book. You can read through those. Just again, showing you how it would be presented in the press. Okay. The multiple regressions, what we've been talking about, is not a foolproof way to rule out all kinds of thirds variables. We can control for as many third variables as we include. So that last, table that I showed you, all those different things have been controlled for. But there's things that the researchers might not have even thought to ask for that could also potentially be third variables, right? So there's no foolproof way if you're doing a correlation study to get rid of any potential third variables. So because you can't control for variables you don't measure. And this type of regression isn't establishing temporal precedence. You would have to do some sort of like longitudinal study or something to determine if watching TV is going to lead to sexual activity and getting pregnant or whatever. So it's good to increase internal validity to an extent, but again, not foolproof. It's not like you're doing an experimental setup where you're controlling for all potential other variables. Another way researchers can get at causality is with something called pattern and parsimony. So pattern and parsimony, basically what this is, the book explains it really well, so read your book. But basically, you're examining a variety of correlational studies that all point in the same causal direction. So we talked about parsimony back in one of the first chapters, which is just going with like the most simplest explanation, just what makes sense, right? You don't want to create, too confusing of an explanation when there's a simple one right in front of you. So basically, with pattern and parsimony, you just look at the results of correlational studies that you already have, and just base your causality off of those. And oftentimes you need to have multiple studies included for this to be significant at all. But your book gives an example of smoking leading to lung cancer, right? Having cigarette smoke being a cause of lung cancer. If researchers were to say this, a lot of times, tobacco companies, whatever, would say, well, you didn't account for third variables, you didn't, have an experimental setup where you measured over time how smoking would lead to this, right? You're just looking at correlational research and you're not controlling for other variables. You could say, people who smoke more also drink more coffee, so how do you know that coffee is not causing this? A lot of different things. But if you look at all of the correlational research out there with smoking, you can come up with different statements showing a pattern and parsimony of causation. So this is the example your book gave. So their statements, they said the longer a person has smoked, the greater chances they have of getting cancer. So again, on its own, this correlation wouldn't be very strong. But when we add it to the other ones, then it gains some strength. So people who stop smoking have lower cancer rates than who continue smoking. Smokers' cancers tend to be in the lungs and of a particular type. Smokers who use filtered cigarettes have somewhat lower rate of cancer than smokers with unfiltered cigarette. People who live with smokers have higher rates of cancer too because of their passive exposure to the same chemicals. So again, all of these are individual correlations, but together it makes it very difficult, to argue that like coffee or something is actually the cause, some sort of third variable. Because you could say the longer a person smoked, the greater chances they are of getting cancer. So you could say, well, they're smoking, and when they're smoking, they're also drinking coffee, so that doesn't make sense. People who stop smoking have lower cancer rates. Again, maybe they stop smoking and stop drinking coffee. You don't know that. But looking at filtered cigarettes versus unfiltered cigarettes, now whatever that coffee or third variable argument was isn't as strong. So pattern and parsimony is just looking at all the correlational research out there and kind of grouping it together in such a way that it kind of accounts for a lot of the third variables because collectively all of this information just rules a lot of stuff out, which is very, very good thing. In the popular press, typically journalists don't represent pattern and parsimony. They're going to report just one new finding, which isn't going to be, reflective of all the science that has gone in to whatever topic is that they're trying to talk about. Science is a very cumulative, thing, whatever you want to call it. So one article is not really going to accurately describe what all is going on in a particular area of study. So just be wary with popular press. Journalists aren't always going to be the most accurate. All right, and the very last section here, looking at mediators, moderators, and third variables. So here we have an example of a mediator. So if we have a relationship between two variables, often we're trying to figure out why this is happening, right? So amount of deep talk increases well-being. So the more deep talk a person has in the relationship, the more well-being they have, right? But why? So a mediator is something that explains why this is changing. The amount of deep talk actually is leading to more stronger social ties, and those quality of social ties lead to overall well-being, right? So that's a mediator, a guy that's in the middle. Mediators versus third variables. So they're both involved in multivariate research designs. Both can be detected using multiple regression, but third variables are external to the bivariate correlation, and they can be problematic. Mediators are internal to the causal variable, and they're not problematic. So again, I posted the video on this for the last chapter when we talked about moderators. Watch that again. I think that video does a great job of explaining it, right? But a third variable, such as education level, being a third variable that's accounting for an increased amount of deep talk and an increased amount of well-being, right? So if we have a third variable, these two actually aren't correlated at all, right? In a third variable, the third variable problem, one thing is leading to both, which makes it seem like there's an association between these two, when in fact there's not. Whereas a mediator, there is an association between these two, but it's just kind of explaining like how that association is happening. Okay. And then the last thing, moderators. So again, mediators are asking why. Why is that association happening? Moderators, we talked about in the last chapter, chapter 8, is asking for whom or when something is happening, right? So we talked about the example from last chapter was cities that had low mobility had higher game attendance regardless of how the team was doing for some sort of sports, right? I forget what cities it was, but basically cities that people didn't move around a lot, regardless of how the team did, there was always high attendance at the game. But there's a moderator, because in cities with more fluid people moving in and out, the game attendance was affected by how well the team was doing, right? So the better the team did, the more people showed up. So a moderator in there would be like how fluid the city's population was. Whereas a lot of people moving in and out, or was a pretty stagnant group of people that were living there. Again, rewatch that video I posted under chapter 8 if you want extra help with this. All right, and this table is from your book. So in your activity, you have a bunch of statements. You have to figure out if there are mediators, moderators, or third variables involved. I would recommend having this page, page 63 in your book open while you're doing that, because it explains, in nice, pretty colors what all these things mean. So take a look at that. And then very last bit here, looking at multivariate designs and the 4 validities. So internal validity, we already discussed that in depth, right? But we also need to think again back about construct validity, external validity, and statistical validity, which we talked about in previous chapters. So internal validity, again, remember we talked about temporal precedence with the different longitudinal designs. If we have, third variables, fourth variables, those multiple regressions that will help account for potential third variables. So they'll help with internal validity, but not necessarily, make the design completely internally valid, but it'll get closer. Construct validities. So again, making sure your measures are reliable and valid. You should review previous chapters if you don't remember what construct validity is. External validity. Need to make sure that your results can generalize to the population. So making sure not only to population, but different contexts, situations. You want to see if your sample was a random sample, or if it was biased at all in any way. And remember, if you don't necessarily have external validity, that doesn't mean that your study should just be thrown out. It's no good, right? You can still publish that study. The information is still useful, but you might just have to do a follow-up study later on with different samples of people to try to get your study to generalize, your findings to generalize to more people. And then statistical validity, right? We want to look at the effect size of beta, and we want to look at statistical significance, or the p-value. So, just all of these things. Make sure you review previous chapters and can kind of apply them to multivariate design like we did for bivariate designs. Okay, that's it for today.